Hello guys, welcome to my channel, and this is my new video on fluid lines and fittings. In aircraft maintenance engineering, aircraft fluid lines are usually made of metal tubing or flexible hose. Metal tubing, also called rigid fluid line, is used in stationary application and where long relatively straight runs are possible. They are widely used in aircraft for fuel, oil, coolant, oxygen, instrument and hydraulic lines. Flexible hose is generally used with moving parts or where the hose is subject to considerable vibration. In fluid lines, there are rigid fluid lines. In rigid fluid lines, tubing materials like copper, aluminum alloy tubing, steel, titanium material, titanium, etc. These are used to make a tubing. In copper, in the early days of aviation, copper tubing was made extensively in aviation fluid applications. In modern aircraft, aluminum alloy, corrosion resistant steel or titanium tubing have generally replaced copper tubing. Aluminum alloy tubing made from 1100 and H14 half hard or 300 3003 H14 half hard is used for general purpose lines of low or negligible fluid pressure such as instrument lines and ventilating conducts. Tubing made from 2024 T3 55 52 0 and 6061 T6 aluminum alloy materials is used in general purpose system of low and medium pressure such as hydraulic, pneumatic 1000 to 1500 psi systems and fuel and oil lines. In steel, corrosion resistant steel tubing, either annealed CRES 304, CRES 321 or CRES 304 half hard is used extensively in high pressure hydraulic system 3000 psi or more for the operation of landing gears, flaps, brakes, and in fire zones. Its higher tensile strength permits the use of tubing with thinner walls. Consequently, the final installation weight is not greater than that of the thicker wall aluminum alloy tubing. Steel lines are used where there is a risk of foreign low risk of foreign object damage FOD, that is the landing gear and wheel well areas. Swedged or MS flareless fittings are used with corrosion resistance tubing, although identification markings for steel tubing differ. Each is usually includes the manufacturer's names. Tubing differ each usually includes the manufacturing or trademark, the Society of Automotive Engineers SAE number and the physical condition of the metal. In this, the society SAE is working for a measure in the number giving to the steels and etc. Titanium. Titanium, it consists of 3Al minus 2.5 V. Titanium 3Al minus 2.5 V tubing and fitting is used extensively in the transport category and high performance aircraft hydraulic system for pressure above 1500 psi. Titanium is 30% stronger than steel and 50% lighter than steel. Cryofit fittings or swedged fitting are used with titanium tubing. Do not use titanium tubing and fittings in any oxygen system assembly. Titanium and titanium alloys are oxygen system assembly. Titanium and titanium alloys are oxygen reactive. If a freshly formed titanium surface is exposed in gaseous oxygen, spontaneous combustion could occur at low pressures. And the another topic of this chapter is material identification. To identify the materials like copper, aluminium, steel, and titanium, etc., the material identification marks have been given to this alloy metals. And before making repairs to any tubing, it is important to make accurate identification of tubing materials. Aluminum alloy, steel or titanium tubing can be identified readily by it slide where it is used as a basic tubing material. However, it is difficult to determine whether a material is carbon steel or stainless steel, or whether it is 1100, 3003, 5052O, 6061, T6 or 2024 T3 aluminum alloy. To positively identify the material used in the original installation, compare code markings of the replacement tubing with the original markings on the tubing being placed. On large aluminum alloy tubing, the alloy designated in stamped on the surface. On small aluminum alloy tubing, the designation may be stamped on the surface, but more often it is shown by a color code, not more than 4 in width, painted at the two ends and approximately midway between the ends of some tubing. When the band consists of two colors, one half with the width is used for each color. If the code marking are hard or impossible to read, it may be necessary to test samples of the material for hardness testing. Now we are going to the another topic of the chapter is sizes. The sizes of the metal tubing is sized by outside diameter OD, which is measured fractionally in sixteenths of an inch. For example, number 6 tubing is 6 by 16 or 3 by 8, and number 8 tubing is 8 by 16 or 1 by 2, and so forth. The tube diameter is printed on all rigid tubing. In addition to the other classification or means of identification, tubing is manufactured in various wall thicknesses. Thus, it is important when the installing tubing to know not only the materials and outside diameter, but also know the thickness of the wall. The wall thickness is printed on the tubing in thousandths of an inch. To determine the inside diameter ID of the tube, subtract twice the wall thickness from the outside diameter. For example, a number of 10 pieces of tubing with a wall thickness of 0.063 has an inside diameter of 0.625 is minus 2 of 0.063 is equals to 0.499 as given example in the given video. And the other topic of this chapter is fabrication of metal tube lines. Damaged tubing and fluid lines should be repaired with new parts whenever possible. Unfortunately, sometimes replacement is impractical and repair is necessary. Scratches, abrasion, or minor corrosion on the outside of fluid lines may be considered negligible and can be smoothed out with a burnishing tool or aluminum wool. Limitation on the amount of damage that can be repaired in this manner are discussed in this chapter under rigid tubing inspection and repair. If a fluid line assembly is to be replaced, the fittings can be often be salvaged, and the repair involves only tube forming and replacement. Tube forming consists of 4 processes: cutting, bending, flaring, and beading. If the tubing is small and made of soft material, the assembly can be formed by hand bending during installation, and the tubing is 1/4 diameter or larger. Hand bending without the aid of tools is impractical. And the another topic of this chapter is tube cutting. Tube cutting is a when cutting tubing is it is important to produce a square end free of burrs. Tubing may be cut with tube cutter or a hacksaw. The cutter can be used with any soft metal tubing such as copper, aluminum, or aluminum alloy. Correct use of the tube cutter is shown in this figure. Special chipless cutters are available for cutting aluminum 6061, T6, corrosion resistant steel, and titanium tubing, and so on. And the second topic of the tube cutting, after tube cutting, there is tube bending. The objective in tube bending is to contain a smooth bend without flattening the tube. Tubing under 1/4 in diameter usually can be bent without the use of a bending tool, and for larger sizes, either portable hand benders or production benders are usually. As the given flowchart is shown, there is an aluminum alloy number and color of band. In 1100, there is the band of color white. That so on, there are different types of number and different types of band color shown in this figure and video and used in AME. And there are such as alternative bending methods when hand or production tube benders are not available or not suitable for a particular bending operation. A filler of metallic composition or of dry sand may be used to facilitate bending. When using this method, cut the tube slightly longer than required, and the extra length is for inserting a plug which may be wooden in each end, and the tube can also be closed by flattening the ends or by soldering metal disc in them. After this process, there is double instruction for rolling type flaring tools. Use these tools only to flare soft copper, aluminum, brass tubing. Do not use with corrosion resistant steel or titanium. Cut the tube squarely and remove all blurs. Slip the flaring nut and sleeve on the tube. Loosen clamping screw used for locking the sliding segment in the die holder. This permits their separation. The tools are self-gauging, and the proper size flare is produced when tubing is clamped flush with the top of the die hook. Insert tubing between the segments of the die block that corresponded to the size of tubing to be flared. And the next topic is double flaring. A double flare is used on soft aluminum alloy tubing 3 by 8 outside diameter and under, and this is necessary to prevent cutting of the flare and failure of the tube assembly under operating. A double flare is smoother and more concentric than a single flare and therefore seals better. It is also more resistant to the shearing effect of torque. Double flaring instructions: deburr the both the inside and outside of the tubing to be flare, cut off the end of the tubing, and all the instruction that is shown in this video. And the next topic is fittings. Rigid tubing may be joined to either an end, such as brake cylinder, another section of either rigid tubing, or to a flexible hose such as a drain line. In the case of connection to an end item or another tube fitting are required. And the next topic is flareless fittings. Although the use of flareless tube fittings eliminates all tube flaring, another operation referred to as presetting is necessary prior to installation of a new flareless tube assembly. Flareless tube assemblies should be preset with the proper size presetting tool or operation. And in this figure, it is a cutaway view of single flared and a double flared as shown, with the tube vents as been shown in this. And the next topic is beading. Tubing may be beaded with a hand beading tool, with a machine beading rolls, or with a grip dies, and the method to be used depends on the diameter and wall thickness of the tube and the material from which it is made. The hand beading tool is used with tubing having 1 by 4 to 1 outside diameter, and the bead is formed by using the beader frame with the proper roller attached. The inside and outside of the tube is lubricated with light oil to reduce the friction between the rollers during beading. And the fluid line identification. Fluid line identifications in aircraft are often identified by markers made up of color codes, words, and geometrical symbols, and these markers identify each line's functions, content, and primary hazard. And the fluid line end fittings, depending on the type and use, fittings have either pipe threads or machine threads. Pipe threads are similar to those used in ordinary plumbing and are tapered both internal and external. External threads are referred to as a male threads, and internal threads are female threads. As shown and in this figure, double flare tools have been shown in below the figure page. And universal bulkhead fittings. On this step, there are step-by-step sleeve cutting edge, and a presetting flareless tube assembly, and a air AN flared fittings consist of sleeve and a nut, and the nut fits over the sleeve and tighten draws the sleeve and tubing flare tightly against a male fitting to form a seal. And tubing used with this type of cone shaped surface with the same angle as the outside of the flare, and the sleeve supports the tube so that vibration does not concentrate at the end edge of the flare and distributes the shearing action over a wider area for added strength. And on the next page, we can see that the above figure is shown as to use the head beading tool cut with the tube cutter, deburr, oil, and revolve tool around tube while tightening handle. And for MS flareless fittings, are designed primarily for high pressure 3000 psi hydraulic system that may be subjected to severe vibration or fluctuating pressure. Using this type of fitting eliminates all tubing flaring, yet provides a safe and strong dependable tube connection. And the fitting consists of three parts: a body, a sleeve, and a nut. And the internal design of the body causes the sleeve to cut into the outside of the tube when the body and nut are joined. And the counterboard shoulder within the body is designed with a reverse angle of 15 degree for steel connectors and 45 degree for aluminum fittings. And this reverse angle prevents inward collapse of the tubing when tightened and provides a partial sealing force to be exerted against the periphery of the counter body. Swaged fitting, a popular repair system for connecting and repairing hydraulic lines on transport category aircraft, is used of Primar switch TM fitting. Switched fitting create a permanent connection that is virtually maintenance free. Switch fitting are used to join hydraulic lines in areas where routine disconnections are not required, and are often used with titanium and corrosion resistant steel tubing. The fittings are installed with portable hydraulically powered tooling which is compact enough to use in tight spaces. If the fittings need to be disconnected, cut the tubing with a tube cutter. Special installation tooling is available in portable kits. Cryofit fittings. Many transport category aircraft use cryofit fittings to join hydraulic lines in areas where routine disconnections are not required. Cryo fittings are standard fittings with a cryogenic sleeve, and the sleeve is made up of shape, memory, alloy, time, TM. And on the next page, the sleeve is manufacturing 3% smaller frozen in liquid nitrogen. And in this we can see that there is a connection between the fuel, lubrication, and pneumatic hydraulic. There are different type of systematic symbols, and ventilation has been shown in this figure. As we can see, the warning symbols as known as a warning symbol, and on the other other options we can see as a fuel flame, and the above and the below things is showing us rigid tubing installation and inspection and connection and torque. There is a connection and torque between never apply compound to the phases of fitting or the flare, as it destroys the metal to metal contact between a fitting and flare, a contact which is necessary to produce the seal. Be sure that the line assembly is properly aligned before tightening the fittings. Do not pull the installation into place with torque on the nut. Correct and incorrect method of installing flared tube assemblies are illustrated in figure 928. Proper torque values are given in. Remember that these torque values are for flared type fittings only. Always tighten fittings to the correct torque value when installing a tube. Over tightening a fitting may badly. And in this figure we can show AN744 to AN930 aluminum alloy metal with steel, brass, aluminum, bronze. In aluminum alloy metal there is a code D. In steel there is a code absence of letter, and in brass there is code B, and aluminum bronze code Z for AN819 sleeve. And we can see the above things are used in the dash. Now indicates the size of tubing for hose for which the fitting is made in 16th of an inch, and this size measures to the outer diameter of tubing, and the inner diameter of hose fittings that have pipe threads are coded by a dash number indicating the pipe size in 1/8 of an inch, and the material code as noted above follows the dash number. And on the next page we can see the identification tubing outer diameter inches, and the of the different types of fitting, bolt or nut size, aluminum alloy tubing bolt fitting on nut torque, and steel tubing bolt fitting or nut torque. For example, 1/1 of the outside diameter there is a fitting bolt or nut size of -2, and in LB, in aluminum alloy tubing bolt for there is 20.3, and so on. We can see that the hose ending fittings and hose assemblies and minimum maximum what equivalent and end fittings, and aluminum alloy with AN9 code or some codes. We can see that the radius and inches, and the steel aluminum alloy. We can see the down figure flared fitting data. Flareless tube installation: tighten the nut by hand until an increase in resistance to turning is encountered. Should it be impossible to run the for the first signs of bottoming, it is important that the final tightening commences at the point where nut just begins to bottom. Use a wrench and turn the nut 1/6 turn and one flat on a hex nut. Use a wrench on the connector to prevent it from turning while tightening the nut. After the tube assembly is installed, the system should be pressure tested. It is permissible to tighten the nut on additional 1/6 number. And in the next page we can see that the sleeve MS, there are different types of sleeves: union, elbow, cross, union elbow, TEM, that has been shown in previous page, also shown in this we can see that the identification of MS marking and the coding, and what the identification D is shown, and in material it is shown by a code like D, B, etc. And for the fitting bolt or nut sizes, -4 size of fitting in 16 inch one by that has been shown in at a -4 category or something like that. And for 21 90 90 for example, it is design part adapter flareless tube to an flared tube. And for prefix MS word is it's also known as a military special specification that has been shown in this videos, and so on. It is just an identification of the things and a typical MS flareless tube fittings. And on the next page, we can see that the rigid tubing inspection and repair. Minor dents and scratches in tubing may be repaired. Scratches or nicks are not deeper than 10% of the wall thickness in aluminum alloy tubing, which are not in the heel of a bend, may be repaired by burnishing with hand tools. And the damage limits for hard, thin walled, corrosion resistant steel and titanium tubing are considerably less than for aluminum tubing and might depend on the aircraft manufacturer. And in this page, we can see the figure like flareless fitting and switch fitting tooling. And in this, we can see that the lower die holder assembly, power unit, how it is shown, how it is inserted, how it is used as a head assembly. You can find the video of these things on YouTube very quickly. And on the next page, we can also see about the some of the perma-switch fitting, perma-light TM fitting, cryo fittings, correct and incorrect methods of tightening flared mixer. In this, we can see of different type of how it is used, correctly fitted and tightened, and incorrectly will damage or flared, something like that. And on the next page, we can see about the hose materials and constructions. And in the hose material is just a pure rubber, is never used in the construction of flexible fluid line. To meet the requirements of strength, durability and workability, among other factors, synthetics are used in place of pure rubber. And synthetic materials most commonly used in the manufacture of the flexible hose are Buna and neoprene, butyl, ethylene, propylene, dyne rubber, EPDM, and Teflon, etc. are used as in hose materials and construction. And Buna N is a synthetic rubber compound that has excellent resistance to petroleum. And neoprene is a synthetic rubber compound that has an acetylene base. It is resistant to petroleum product, is not as good as Buna N, but it has a better abrasive resistant. Do you not use for phosphate ester base. And butyl is a synthetic compound made from petroleum raw materials. It is an excellent material to use with phosphate base hydraulic fluid. Cyclol TM do not use with petroleum products. And hose identification, lay lines and identification marking consist of lines, letters and numbers and printed on the hose. And the next page, we can see the type of failure used in the hose and a dent removal using a bullet, and a repair method is shown in the next page. And the other page, flexible hose inspection has been shown, and a fabrication and replacement of a flexible hose has been shown. And in this in this the first figure at 931, we can see that the flexible fluid connection assembly, and on the first we can see the clamp and the minimum distance between 1 by 4 has been shown, and a tubing hose fittings minimum gap G shall be 1 by 2 what you OD specification has been shown in this video. And flexible hose with stainless bride also has been shown in video. As you can see, you can find the videos of these things on YouTube and etc. for on also Google also and etc. And a flexible hose inspection, check the hose and hose assemblies for deterioration, HEC inspection, leakage, separation of the cover, or it is just nothing but a flexible hose inspection. And fabrication and replacement of flexible hose. To make a hose assembly, select the proper size hose and end fitting. And MS type end fittings for flexible hose are detachable and may be reused if determined to be serviceable, and the inside diameter of the fitting is the same as the inside diameter of the hose to which it is attached. And in the next page, we can see the suggested handling of performed hose and flexible hose testing, and all these things are shown in this page. And in 920, we can see the specification number like a single wire braid fabric covered. And in MIL part number MIL H873, it's just nothing but a specification number. In the first, military limitations has been shown, and tube size of outside diameter in inches, outside ID in inches, hose size outside diameter in inches, recommended operating pressure PSI, minimum burst pressure, max proof pressure, mean bend radius, and all these things are constructions. Seamless synthetic rubber inner tube reinforced, and all of this stuff has been shown in this multiple wire braid rubber required, and in single wire braid fabric recovered. And in the next page, we can see that the hose fittings, installation of flexible hose assemblies. In installation of flexible hose fittings, slack, flex, twisting, bending, clearance. It is shown how it is used to be, and hose assembly must not be installed in manner that causes a mechanical load on the hose. It is just used to join two parts in the same thing. And in planning hose line inspections, hose clamps to ensure proper sealing of hose collection and to prevent breaking hose clamps or damaging the hose, follow the as been shown in the next page. And for hose clamp tightening, self sealing hose approximately 15 lb, finger tight plus 2 complete turns, and finger tight plus 2 1 by 2 complete turns. And it is shown in different types of clamps and radius. And to support tube at least 1 by 4 from edge to hole, it is shown in the rubber cushion clamp and maximum distance between supports. And in this video we can show we have seen the topics related about the fluid and fittings, and in the next part we can see the